So now we are approaching this important aspect, the brine that comes out from a desalination plant, what we can do and what are the technological options in terms of different possibilities.
Thank you, Giorgio, for the introduction. Good morning, bon dia, buenos dias, buongiorno. A lot of different countries here.
Yeah.
The objective of this presentation will be
Sorry, is it this?
Yeah, it is. Yeah, thank you. It will be to give an introduction to the brine valorization technologies. There will be two more presentations about this from Giorgio and Andrea. So I'm pretty sure that most of the people here are well aware of the this topic. Okay. So I will start just a little bit telling who we are and about our desalination platform, the Desal Plus Living Lab, giving few statistics on desalination and reverse osmosis. And then I'm gonna talk as an introduction. I'm gonna get a bit deep on what the brine chemical composition is from a seawater reverse osmosis. And then a little bit talking about the brine valorization technologies available at the moment and what's the state of the art. Then we're gonna go just slightly talking about strengths and weakness of this desalination valorization, desalination brine valorization. And then we'll talk about the open testbed platform that we have in Pozo Izquierdo in Gran Canaria, where the next fast track school is gonna take place. Maybe it's September, October, we don't know yet the date, but you're more than welcome to come here and check it. So the Desal Plus Living Lab is a fully equipped public-private ecosystem where, well, managers, researchers, technicians, water bodies, industry cooperate, research, make developments, innovation, and the validation of the water desalination technologies. Also coupled with renewable energies, as my colleague Tony presented with the PVRO presentation, is composed of ITC, so the Canary Islands Institute of Technology, the two Canarian universities, the Society of Economic Promotion of Gran Canaria, and also the research agency, regional research agency in the Canary Islands. It started in 2017, and the idea is to be a leading hub of skills and innovation in both desalination and water energy nexus. Our infrastructure mainly is in Gran Canaria and Tenerife, in the Canary Islands, but we also have some infrastructure in Cape Verde, Senegal, and Mauritania, where my colleague Javier, he takes care of most of the projects in the African side. You can see an aerial view here of Pozo Izquierdo, where our main infrastructures are, where the fast track school, the second one, is going to be located. So I'm pretty sure that everybody knows a little bit more. So I'm not going to go deep into this data, but seawater desalination represents around 55% of the total installed capacity worldwide. And the estimated water installed capacity is around 100 million cubic meters per day. Being reverse osmosis, the reverse osmosis technology represents about 80% of the operational desalination plants. And if we talk about the on construction, so the ones that are being built right now, it represents more than 90%. This is just to give insight of what's the daily volume of brine produced in the Canary Islands. Is nearly 600,000 cubic meters per day nowadays. So what to do with the brine is the question. So at the moment, we just discharge it into the sea. It's a waste. So the idea is to transform this waste into something valuable, into resources. And we do that by applying these brine valorization technologies that we're going to have in three different presentations today. So we said, what's the composition of this brine from the reverse osmosis process? So the exact brine chemical composition will depend on multiple factors, as field water is not the same if it's located in the Mediterranean Sea or in the Atlantic Ocean, or if it's Chile or Australia, it's going to be a different concentration. Also the type of intake. So it's not the same. It's not going to be the same if it's from a beach well or an open sea intake. The recovery rate of the reverse osmosis plant, of course, the pretreatment used, and the type of membranes that we use. Whatsoever, the main ions will always be chloride, sodium sulfate, magnesium, calcium, potassium, bicarbonate, and bromide in that order. And this is a list of the compounds that we can achieve or that are present in the brine if we take into account these major ion compounds. So this is well known, but we wanted to study the exact brine composition, the chemical composition in the Canary Islands. So we did a study. We selected 20 seawater desalination plants with a very heterogeneous selection. We wanted to choose pilot plants, medium scale, large scale plants. We selected open intake or beach well intake. We also selected with chemical pretreatment, without chemical pretreatment. So we wanted to cover a large amount of different desalination plants. So we have a comprehensive result. Then what we did was we gave to the desalination plants, or actually went there, fill out a form with all the operational parameters. So then we could relate these results depending on the operational parameters of each desalination plant. Then we also took some samples in different times of the year and sent it to an external laboratory where we studied a total of 37 physicochemical parameters. These were, well, some of the results. There's a published paper where we can go in deep. We don't have time today for this, but if you're interested, I can give you the information later on. So this is more or less what standard brine, desalination brine will have if we consider 63,000 milligrams per liter. And what we could see is it didn't matter much the different desalination plants that we selected. The major ions composition, the ratio between their percentages, this is percentage related to the total dissolved solids, was pretty stable. So these are the percentage of the major ions contained in the brine. But then we also did some studies of the non-major ions that we will see in the next slide. Also, according to this, I wanted to ask a question, but it's already here. Because mainly when I've talked, I'm sure you already know because you work on this field. But if you ask to somebody that has no knowledge on this, how much percentage of sodium chloride is contained in seawater or desalination brine, they would probably think it's about 100% or 90-something large percent, which is not true. We have here the combination of sodium ions on its own and chloride ions is up around 85% of the total dissolved solids contained both in seawater and seawater desalination brine. So these are some of the results we also got. We could see some difference between the type of intake, which is the factor that made the most differences between the brines. For example, in the major ion concentrations, we could see that open sea intake was a lot higher, well, not a lot, but a bit higher than the other desalination plants with the closed intake or beach well intake. Also, in the Canary Islands, in being volcanic islands, the concentration of silica was a lot higher in those that are filtered by their own surface or the terrain, the natural filtration. And we could see a lot higher silica concentration than those on the open seawater. And then we performed some ionic balance in all the desalination plants. We can see the percentage, the percent error on these lines. So it was quite low, errors below 4%. And this is, as I said before, the sodium chloride comparative analysis between all the different desalination plants. This is only taken 10, not the 20, because that was done before at the first time. We can see the difference as well between around the 85% of sodium plus chloride, but then the stoichiometric sodium chloride, that is the actual, because not all the sodium will be linked to chloride and vice versa. So it's around 75%, between 70 to 75% of the sodium chloride that you can actually get from it. If it's one of your targets, then you need to take this into account. So the brine valorization technologies are mainly divided into 3 different groups: the recovery of chemical products, the electricity generation, and also the carbon capture and utilization, which also tries to tackle another challenge, which is the CO2 emissions in the atmosphere. This is a generic diagram of a brine valorization process. You start with your seawater reverse osmosis brine, and instead of getting into the sea, it goes generally through 3 different stages. Pre-treatment, where you can get some byproducts in this stage. Mainly in the pre-treatment, you try to separate the multivalent ions from the monovalent ions, mainly sodium and chloride. Then the concentration, which is optional, depends on the technology, but you can obtain more fresh water, though increasing the recovery rate of your system. And then the concentrated brine, or the pre-treated brine, if we don't do the concentration step, goes to the conversion step, which is the last stage, where you can obtain byproducts, mainly sodium and chloride byproducts, energy, as we saw before, and then fresh water or low salinity brine to be discharged at the similar concentration that seawater, or may even, depending on the technologies, you can get zero liquid discharge, and that's the objective of the Sol2 project. These are some examples of different technologies, depending on which stage are they used. I won't go deep into them because both George and Andrea will explain some of them in the following presentations. Just mentioning carbon capture and utilization, for example, mainly to produce calcium and magnesium carbonate, nanofiltration, chemical precipitation, again, to get rid of the multivalent compounds and the ions, electrodialysis, which is a combination, which is quite interesting. Combination of electrodialysis with selective membranes. Concentration, we have the membrane distillation, as Guillermo explained before, electrodialysis, metathesis, which is a different one where you can obtain different salts of sodium and chloride. Then we also have the another membrane technologies, something called osmotically assisted reverse osmosis. There are several names. There are also flow cascade, reverse osmosis, counter current reverse osmosis, but they're more or less same principle. In this case, we also have ultra high pressure reverse osmosis, which it works on the pressures of 120 bars, something like this. The beauty of the SWRO system is you maintain the 60 something, 70 bars threshold all around the concentration of the brine. And it's a combination of reverse osmosis and forward osmosis technologies. Then electrolysis, crystallizers, bipolar membrane electrodialysis, and then the electricity generation. There are two main technologies, the reverse electrodialysis and the pressure retarded osmosis. So what are the strengths? Well, the strengths, you have the environmental impact mitigation or elimination of brine discharge, depending on the technology. The zero liquid discharge or hybrid solutions with existing technology between existing or more mature technologies and emerging technologies. The potential integration with either renewable energies or waste heat. New employment and business opportunities, of course. Resource and energy recovery, and an increase on the desalinated water production with your system with the same intake. What are the main impacts and barriers of the desalination brine valorization? The intensive pre-treatment, so is not main, for the most of the technologies, is not enough with the pre-treatment of the reverse osmosis. You have to you have to perform an extensive pre-treatment in order to get the maximum purity of the products that you will produce in order to be competitive with the existing technologies. The emerging technologies have very low TRL, so that's why we're working on it to increase this TRL and achieve commercialization on some of these systems. Environmental impact associated mainly to the high energy consumption, high CapEx on OpEx, limited available research data, although we're working on it and there is a lot of research data inside this room. Outside this room, there are not much. So we need to keep working on it and keep bringing people to work on this field. The commercialization of the byproducts, because I've seen many times, oh yeah, you can obtain whatever tons of this particular product, and yeah, but what do we do with it? Does it have the enough purity to get into the market? Do you have a market, local market, or do you need to sell it outside? Is there a market for it? Can you compete with the existing market? And then some legal restrictions on some of the technologies or lack of specific materials or components that are being developed and they need more matureness, and also lack of specific simulation software tools that will help a lot. I'm sure that I've seen some of them already specific to some of these emerging technologies, but we will need to develop much more, especially in the area of artificial intelligence. So it could help improve a lot in these kind of technologies. So just to finalize my presentation, we'll present the open test platform on desalination brine valorization that we have in Gran Canaria, in Pozo Izquierdo. It's being created with funding from Cabildo of Gran Canaria and the government of Spain. We detected this worldwide need, which is we think we need to boost the research and development with high technical locations, specialized, dedicated to applied research on brine valorization using actual desalination brines, and not only one, but several, as I will show in the following slide. The main objectives: analyzing, testing, and optimizing the different process steps or the stages that I showed before. Position the Canary Islands as a desalination brine innovation hub, as it is nowadays for desalination. but also attract companies with pre-market solution, companies that need these kind of inputs, and it's not easy to get it. It's not easy to get them. It's not easy to go to a desalination plant and say, "Oh, can you give me some of your brine? I'll be here doing some of my research. You know, I won't disturb." So having these possibilities is very attractive. Actually, we have a lot of companies coming in and testing their products and their technologies in our site, and increasing the qualification of local researchers and technicians, of course. These are some of the pilot plants that we have in our facilities, especially about brine valorization. We have the pilot plant, reverse osmosis pilot plants, a forward osmosis pilot plant, nanofiltration, and recently we also acquired a osmotically assisted reverse osmosis pilot plant for brine concentration. So this is what the open testbed looks like in Pozo Izquierdo. We have our seawater beach wells where we provide seawater to our desal plus reverse osmosis pilot plant. And the new SWRO 2.0 that Tony mentioned in his presentation, these are one-stage reverse osmosis plants with 40 to 45% recovery, but we also have a brine line from a commercial two-stage RO plant, which recovery is around 55%, so it's already more concentrated, which is an advantage. Then they can all go to our demonstration area for brine concentration and valorization technologies, or to our nanofiltration pilot plant, and then we can go get the different dye stream that has several technologies associated to that input as well, not only the monovalent bridge stream. And then we also have the brine discharge to the sea. This is another important thing, because you cannot, because we mix this final brine discharge with the sureste, so we have a bit more leeway on what to discharge, because it won't affect the final discharge that much. So that's another advantage. And that's it. Thank you very much for your attention.
So on time, right on time.
That's good.
So maybe we have time also for questions, or just to...
Maybe I will start. Thank you. I would like to have your opinion. I mean, you mentioned many important points on the attractiveness of brine valorization potential. One of these was commercialization of products.
Yeah.
It's a very open question. Which is, in your opinion, the most valuable product you could get out? Have you analyzed the economic value of potential products? And
yes, for example, this is a very interesting question, and it depends on the location. And we did a study, local study in the Canary Islands, and we could see that, for example, with different technologies, electrodialysis or bipolar, maybe, you know, you produce sodium hydroxide or hydrochloric acid. So sodium hydroxide has a higher price than sodium hypochlorite. But in the Canary Islands, because of the amount of desalination plants and because of the amount of swimming pools, the sodium hypochlorite is a much important target, and it's a key chemical product. Although it's cheaper, it's a key chemical product in terms of high demand. So, for example, I think the sodium hypochlorite generation directly, or high quality sodium chloride salt for the production of the sodium hypochlorite will be chlorination. They will be the main target in the Canary Islands. Actually, in the Canary Islands, there is only one company that produces sodium hypochlorite, because you know that it degrades with time. So we import it from different places. It will get a lower concentration. So there is one company producing sodium hypochlorite in Tenerife, and they get the sodium chloride high purity sodium chloride from the Netherlands. Because the sodium chloride that we produce is not, the purity is not high.
The grade, yeah.
Yes, so this is very important. This is a niche market that we have in the Canary Islands. We're able to produce sodium chloride with high purity, so high purity grade. Then it's gonna be a lot cheaper, and it's gonna be, you know, also for the environment. It's not the same bringing sodium chloride from the Netherlands. So I think that's the
Very interesting
yes.
point. I mean, that's very site specific. I mean, the region, I mean, that area, the Canary Islands. So
Thank
for sure, it's in the small island. I think also we will be presenting maybe a few things later on in my presentation, at least just to mention. But for sure, could be very different, the technical solution.
Yeah,
brine valorization, depending on what you get on the islands and the size of the island, the economy of the island, and the circumstances very side dependent. Okay, thank you so much. Thank you so much. So now I think we are approaching the end of the morning. So with the last presentation, and the last presentation will be given